Hello there, I'm Thomas Hatsios, the pilot captain flying the Boeing 777-300 ERX airplane in tonight's flight. From Zurich International, we're going to be overflying Switzerland and Germany, and then coming back to Switzerland and Zurich runway 14 airport for landing. So right now I'm in the cockpit of the pre-takeoff preparation for the Boeing 777-300 ERX airplane. So I'm gonna show you things like the systems of the primary flight display with the airspeed displayed and the barometric altitude above the sea level, the radio altitude, the magnetic through heading, the autopilot and the auto thrust modes connected with the vertical and then lateral navigation in the primary flight display. The flight guidance displays the horizontal situation indicator of the aircraft displayed in degrees with the flight director symbol or the autopilot connect symbol. I'm gonna show you also things like the autopilot and flight director system panel with the auto thrust mode and the autopilot engage and disengage switches and the auto thrust engage and disengage switches, and also the speed guidance of the aircraft, the speed switch, the speed select switch, the heading select switch with the heading select, and also the bank angle limit of the autopilot when the aircraft is flying. I'm going to show you the lateral navigation and the vertical navigation modes, the flight level change mode of the speed guidance, the N1, the speed switch, the speed hold switch, and also the rate of climb and descent in hundreds and thousands of feet, or the flight path angle of the aircraft switch with the VS vertical speed switch, hold switch, and also the altitude switch with the altitude hold switch. So all these switches are the press hold. So I'm also going to be showing you the navigation display with the GPS and the terrain data with the airports, the waypoints, the VOR stations, the ADS. I'm going to show you the magnetic through heading of the aircraft. I'm going to show you other things like the engines, the N1, which is the low speed, low pressure compressor stage of the engine, the exhaust gas temperature, the flat setting. I'm going to be showing you also other things like the flight management computer with the aircraft data input, the weight of the aircraft, the takeoff speeds, the flight speed, the cruise speed, the descent speed, and approach speed, and also landing runway and selection, departing and arriving runways and airports, and also the flight path. We create a horizontal and vertical navigation flight plan for the aircraft to follow manually with the autopilot. So I'm gonna show you other things in the overhead panel, like the IDTs, the integrated drive generators. We have two IDTs, one left engine and one right engine driven. Electromagnetic alternators that produce around 75,000 kilovolts or 75,000 watts of electrical alternator that power on 115 volts, 400 Hz frequency, 3-phase alternate current, which can be converted using other static inverter, other transformer rectifiers into direct current to cover the direct current needs. And also we have the backup generators, and also for the left and the right engine we also have the batteries, the APU battery, the primary battery, 28 volts, about 40 ampere hours of alternate current. We also have the APU switch. We use the APU for covering alternate current electrical needs, usually for starting the aircraft engine, and also when we have an engine failure in flight. So this also covers about 35,000 kilovolts of additional alternate current, about 75,000 watts, 115 volts again, 400 Hz frequency, 3-phase current. We also have the hydraulic pumps, left and right engine, and the C1 and C2 backup hydraulic fluid pumps. We also have the fuel dump for fuel jettison in flight, the dump fuel which is not necessary usually for landing overweight. And also we have the left and right wing engine and the center tank of the aircraft, fuel tank, with a forward and the aft fuel pump. I'm gonna show you also this with the X-feed pump, the cross-feed pump, and also the cross-feed valves actually, and also the APU feed. I'm gonna show you all these things in the ACAS, in the lower ACAS display, the instrumentation controller system. We also have the electronic engine control computers, left and right engine, with the auto start system for the left and the right engine, which control the FADEX, the full authority digital electronic control computers of the left and right engine, which controls and monitors all the things displayed in the ACAS, in the upper ACAS and the lower ACAS, the engine indication controller system displayed, like the N1, which is low speed, low pressure compressor stage of the engine, the exhaust gas temperature, the N2, which is the high pressure, high speed rotor stage of the turbofan turbojet engine of this aeroplane, the oil quantity and temperature, the fuel flow for each engine in thousands of kilograms per engine per hour. We have also the vibrations of the engine and other factors. So I'm gonna be showing you also things like the cabin pressurization of the aircraft, and the left and the right engine bleed from the left and the right engine, and also the APU bleed, which is uses bleed air, compressed bleed air from the engine or the APU, from the APU for starting the engines in the ground, and from the left and the right engine for things like the cabin pressurization, the hydraulic fluid pressurization, and also the engine and wing anti-ice and the air conditioning and ventilation of the aircraft. You also have the cabin pressurization system, which is usually automatic or alternate with the outflow valve controller. With the pressurize, we open the valve to the pressurized aircraft condition, or close the valve to pressurize it in flight. And I'm gonna start showing you. We also have the thrust levers of the aircraft with the engine thrust. I'm gonna show you this also. We use the thrust levers to control the thrust, to use the thrust reverse, and also the takeoff go around modes of the autopilot and auto thrust system, and the auto thrust disconnect switch. We also have the flaps lever, the stabilizer trim of the horizontal tail of the airplane, of the aircraft, and also we have the fuel flow to the engines, the cutout switches, the electronic cutout switches for the auto trim system, for the electronic auto trim system, so electrical oxygen system, the C and the R. And also we have the stabilizer trim, normal and alternate handle switch. We have the speed brake switch, and also the radio navigation communication panel with the transponder. So the stabilizer trim that I'm telling you is used to stabilize the aircraft in flight using the horizontal stabilizer at the tail of the aircraft and its angle of attack position, using aerodynamic forces to pitch up and pitch down the aircraft around its center of gravity and center of pressure, or aerodynamic pressure in the wings when it's flying. So we also have the control column and yoke, the control column and the control wheel of the aeroplane, of the Boeing 777-300ERX, with the control with the yoke of the Boeing aircraft. So I'm gonna use a side stick from the Airbus to, instead of using a control yoke for this flight, I'm gonna show you how to do it. So I'm gonna start right now, starting with the flight controls of the aircraft. So I'm gonna show you here. You can see we have the yoke, the control column pitching up and pitching down the aircraft, and also the control wheel bang rolling left and right the aircraft, and also we have the rudder pedals for the vertical tail of the aircraft. So the horizontal tail elevator part is moving up and down like this, and the ailerons and the spoilers in the left and right wing like this, the rudder in the vertical tail like this. So we also have the speed brakes and the flaps with the slats, which are secondary flight control. So you can see the stabilizer trim position here, using this switch. The autopilot disconnect also button here, the aileron trim. We have the normal and the alternate stabilizer trim also here, and the position of the nose, or down or nose up of the horizontal stabilizer, the rudder trim, and you can see the radio communications panel. You can see the overhead panel here. So I will show you now, I was explaining you about this, about the flight control. So I will show you now, we have this side stick here for instead of yoke. So we pitch up and pitch down the aircraft nose position by using aerodynamic forces in the tail of the aircraft to pitch up around its aerodynamic center of pressure in the forward, left and right wing, and the center of gravity. So we barrel roll also left and right, using also aerodynamic forces around between the left and right wing, to increase and decrease the lift between the two wings, to barrel roll left and right either way. Pitch up, pitch down using the tail, the horizontal tail, and the vertical tail, which is the rudder, to go the aircraft left and right. You also have the stabilizer trim here and the flap settings usually, and the thrust levers. So so I will show you now. You can see here is the pitch up and pitch down, the barrel roll left and right. You also have the display here with the flight controls. So here we have the flight controls. You can see the speed brakes extend here, left and the right, the wing ailerons and flaperons, the elevator of the aircraft picks up and picks down. You can see the engines of the wings of the airplane, the Boeing 777. So we have the spoilers left and right wing, like 1, 2, plus 5, 7, 7 in each wing spoiler. We have the inboard and the outboard ailerons. You can see the stabilizer trim. I can pitch it up like 435 right now. So if I show you outside, We have like 10 minutes left for this flight. 1 hour. So I will show you now how to use the side stick and the exterior view of the flight controls, like the elevator, the rudder, and the aileron. So you can see here in the aircraft, and also you can see I have this the side stick I'm telling you. So pitching up and pitching down, you can see the elevator and the aileron, bunker left and right, and also the rudder position. So you can see here the elevator moving up and down, the horizontal tail part, the rear part, trailing leads of the elevator, the trailing leads of the rudder, and also the aileron and the spoilers, moving right, moving left, moving right again, moving left the other way. So you can see the input from the side stick is proportional to the flight control surface's movement, as you can see. So the side stick movement, as I said, is proportional to the flight controls, like the elevator picks up and picks down the ailerons, the spoilers, and the flaperons, bunker right and left, and also the rudder pedals, left and right, the vertical tail of the aircraft. So I will go inside to show you the rest of the aircraft, the cockpit instruments, and how to make an engine start demonstration. So this is so much for the flight controls and the outside view. You can see where we are. I'm gonna make an engine start very quickly. We have about an hour for this flight. So we have an hour exactly for this flight. I'm gonna start right now. You can see here is the primary flight display. If I turn on the flight director here, you will see the FLD direct here symbol. The airspeed displayed, which is minimum airspeed displayed. We have actually airspeed 0 and ground speed 0. So the barometric altitude above the sea level, 1,430 feet minus 2, which is the radio altitude, the takeoff go around, the airspeed selected and the altitude selected. The autopilot here. You can change this. We can depress it. We can also select a new altitude here, a higher altitude for this airplane, like our cruise altitude. We can also select a different heading here using this switch. The heading select, the altitude select, the vertical speed here select, the LNAV and the VNAV, and the flight level change, the auto thrust and the glide mode. So which is here the heading of the aircraft. And with the press also, we can use the hold. We can use the vertical speed, flight path angle here. It's now it's negative, is descent. Now it's positive, is the climb. You can change into angles here with the grid, like minus 0.1 or plus 1.5 degrees. So you can see the auto thrust here, the connect and disconnect here switch. You can see the auto throttle left, disconnect. The auto throttle right now is disconnect. So we have we can turn on the autopilot using this switch here. You will see the autopilot, the flight director system. We can disconnect it using either this switch here, or we can use this switch here in the yoke of the aircraft, like this. Here you will see now the flight director and the autopilot disconnect here. So we reconnect it to one. Disconnect again using the other switch. You will see the autopilot disconnect here. Turn on again. Cancel this warning. Right. So I will start. So now we have the modes here, the flight mode annunciator. We have the navigation display here. You can see I can select the range, like more airports or more terrain to display. You can use also the waypoints. We can use other things to display. We also have the aircraft flying around, traffic alert, TA only. We can change this using this switch here. We have a resolution advisor also. So we can test this. You see here is the traffic mode. Because says fast, so we have the displays, the other displays here, what I'm telling you. So here's the overhead panel. You can see some switches here. So maybe I can use this. I will start the APU maybe now. I will show you here. We have so we have the engines here. If I move the thrust levers forward, you will see the speed breaker retracts automatically, and we have the N1 increasing, which is the low speed, low pressure coverage stage of the engine, the exhaust gas temperature, and Celsius decrease, the flaps down. We have the duct pressure from the engines into the cabin pressurization system, the N2, which is the high speed, high pressure compressor stage of the turbofantric engine, the fuel flow 6,200 kilograms per engine per hour, the pressure or temperature or quantity and the vibration of the engines. So we move this down and maybe use the thrust reverse. You will see the reverse thrust is engaged here. This mode is green, the reverse display. So we use pull the reverse if we want. If I come outside here, you will see the thrust reverses blocker doors are deployed to reverse the engine thrust. So retract the thrust reverses again. So we have the studs here. We have the hydraulic pressure. So it has PSI. The APU is off right now. So if I come in this view here in the cockpit, in the overhead panel, we are using this overhead upper panel. You will see things like inside we have the circuit breakers. So you can see here. We have the thrust levers forward, the speed brakes down. So I'm gonna show you some modes here. So we have the APU. We need to turn on the APU into the start position for a few seconds. So we have the primary flight computers here because this is a fly-by-wire aircraft. We have the ADIRU on and off here, which manages the GPS, and we have to reset it, the APU. Maybe I come here again. We have the electrical. You can see the battery on. Still running. The APU is still running. I'm gonna show you in a second what to do with the APU. Auxiliary power unit. So we have here other things. This is the electrical, the left and right engine integrated drive generator, 115,000 kilovolts or 75,000, 115 volts, 75,000 kilovolts, 75,000 watts. Each one left and right engine. The backup generator, 115 volts, 400 hertz frequency of alternate current. We have the left and the right bus ties, the battery and the APU generator. I believe we have the RPMs now full for this, so we can turn off this the grid drive generators, the alternate current. You're gonna see we have no reconfiguration. We have the APU on, that's why. So you only need you can see we lost the IRS alignment here. The displays because of the ADIRU. We turn off the ADIRU, so we turn it on again. We need to fix the position with the Lszh and enter the GPS position. So we're gonna have the alignment again instantly. For this simulation takes like 10 minutes actually. So we come back in the overhead panel. So I'll tell you, this is the ADIRU, the air data inertia reference unit, which displays 3 or 2 depends GPSs, and also the barometric and anemometric data. The barometric altitude, the radio altitude, magnetic cruise heading, the angle of attack of the aircraft, the barometric pressure, the GPS position, and also the terrain data display, the terrain map. We have other things, red GPS position. So also we have the gyroscopic acceleration and deceleration of the aircraft. This is gyroscope, laser gyro. So we have ground proximity, passenger oxygen, window heat. We turn off just for display the hydraulics and turn them on again. This is the hydraulic pumps, left and right. You can see the 4 messages for the engines. So this is gonna show you some faults here in the messages. So as it happens when we turn on the engine, so I'm gonna come very quickly. Here's the electronic engine control computers, the cargo fire discharge. So we have to leave this in the normal, all the alternate mode, the engine starter here, the auto start on and off. You can start the engines like that. So we can also jettison fuel here in flight, select the amount to jettison. We have the left and right wing pumps and the crossfit valves. This is for the APU. You will see in a while the RDIs, wing and engine RDIs. The pressurization, automatic now or manual like that, and use these controllers in manual mode. and also the other selective manual mode. So we have the left and right engine bleed, compressed air. We have 30 minutes, so about 50 minutes to go. So you can see you can use something like that for starting the engine using only the APU compressed air and the left engine. Then we're gonna use the right engine. So you will see also the messages here displayed, and also APU bleed lost wing right cylinder. I will show you also in the other display. So turn this on again for making an engine start. So this is most of the cockpit in this view. I'm gonna come in the other view. So I will show you the systems. I will show you now. So we have the engines, as I told you, the status, the checklist. So we have the checklist complete here for before takeoff, for instance, or here we have a failure. So we have, for instance, before takeoff, before start, we're gonna start the engine. The items to complete here, and the checklist is complete here, as you can see. We also have the non-normal, like we have a failure, for instance. Engines and APU, let's say we have a failure. What we need to do, we have a failed engine. Engine fail left, no. So we select the item and continue what happened with the aircraft. And what we need to do, restart is needed, yes. Monitor the exhaust gas temperature, engine may accelerate to idle. This is the Boeing 777 item. We go into the 3. No. Slow acceleration. We select each item and continue. You can see what we need to do to restart the engine if we are in less than 70 knots. We have different item each time. Continue. Okay, and this I believe will complete this item now. So we go in the normal menu. We also have the communications here, the control tower. We have the synoptics here. The doors are closed, the cabin is pressurized right now of the aircraft. So we have the landing gear. You can see the pressurization of the tires and the temperature of the brakes, and also the nose wheel. We have the electrical left and right engine. As I told you, the IDT is a great start generator, 115 volts, 400 Hz frequency. This is the green line. Here the left and the right engine, and also the APU here, the overhead panel, and the battery display. And also you can see with green we have the flow of electrical, 115 volts, 400 Hz, alternate current frequency, which is converted into direct current. Into wide use there is no flow. APU generator is on. You can see left and right drive and the backup generators. We also have the main battery volts and the APU battery. So we'll go to the next item. We have hydraulic power, left and right engine, and the backup generators. The demand here, the switch is primary. You can see 3000 psi, and the consumers of the pressure 3000 psi. The consumers, the flaps, slats, aileron, spoilers, rudder, stabilizer trim, left and right reverse. for the engines, and the landing gear and alternate manual and normal braking. So this is the hydraulic here. The switch is the primary demand, and you can see here in this display. So we have the fuel here. You can see the left and the right wing engines at the quantity of fuel 23,500 kilograms in each. The cross feed on. So if we turn off the and leave, for instance, fuel pumps on, we're gonna keep having on one pump. We're gonna having fuel flow to both engines. So we have the APU here. Also we can see the engine symbol with the low and high pressure fuel valves on. With green is the flow, with white is no flow from the center tank. We have no fuel. So here is the air system. You can see the compressed air from the left. You can see the left and right engine of the aircraft, the compressor for the air conditioning and cabin pressurization, left and right packs. We have one pack off, I believe, by mistake. We need it in the on position, in the auto. You see here. We still have the off. So this is most of the systems. You can see the left and right engine intermediate in high pressure compressor state. You can see if we move the thrust levers forward, we have increase in the duct pressure. You can go higher the duct press here. If we move them down to the idle, we have less duct pressure. It goes down. So this duct pressure also the APUs use as white line. The APU is on, running the spring. We have the green line also from the left and right engine for cabin pressurization, wing and engine at the ice, and also the hydraulic fluid compression. So you can see the thrust levers also modified. Besides the thrust of the aircraft, the cabin the pressurizer used for cabin pressurization and hydraulic fluid quantities. So you can see the valves here, the intermediate high pressure, and the engine starter here we're gonna use for starting the engine. I believe this is most of the items used for this. So we have about 40 minutes to go. We can see here we have the stabilizer trim, the electric trim cutout switches for the autopilot. In the auto thrust, the fuel run here, the fuel valves, the fuel the fire extinguishers for the left and right engine, the radio communication panel, contacting another flight. So maybe we're gonna turn off here display. So we use the engine display here. We're gonna turn off the left and the right engine. Okay, you will see the fuel flow go to zero here. Zero fuel flow, and the N2 decreases, also the N1, and the exhaust gas temperature decreases. You can see the configuration. We have no direct drive generators in the overhead panel, no alternate current from the engines. Gonna talk to you in another flight more detail about this. So if we come here, you will see the engine spinning coming down to slow down. This is the right and the left engine, the right wing and the left engine wing. So we have no engine spinning. It's gonna stop completely. So we come here in this view. You can see also the left wing engine, the left wing surface. So I'm gonna use the engine auto start now for the left wing engine first. It's gonna be automatic. So we're gonna see this modification now. The N1 increases and the exhaust temperature. We have zero exhaust temperature in the other side engine. So the N2 increases above 20%. We can turn on the fuel flow. The fuel flow is zero. All this is controlled by the FADEC, as I said, the full authority digital electronic engine control computer. So this is around time. You can see we start the left wing engine here. of this aircraft. So we have the engine spinning here. You can see the spinning of the left wing engine, the starter and the front fan of the turbojet engine. So fuel flow is 0, we turn on the fuel flow, the left wing engine to the run. So you're gonna see the fuel flow in the end to increase from 0 up to 0.5, 6. So we come here, you see the engine spinning more rapidly now. So this is the engine spinning fast right now. We have full engine power, right wing. So I'm gonna show you the other side wing now. You can see this engine start, the other one is still off. So we come again in the overhead panel, start the right wing engine now. Auto start system, the FADEX, the full authority digital engine control computers, control and monitor the N1, the exhaust gas temperature, the N2, the fuel flow, the N2 which is the high pressure, high speed compressor stage of the engine, the N1 which is the low speed, low pressure compressor stage of the engine, the fuel flow, the oil pressure, temperature, quantity, and the vibration, and some other factors, but the FADEX. So the N2 is above 20%, we can start the fuel flow now. The fuel flow run, you can see the engine spinning rapidly now. We have quite a lot of compression, 30% N2. Fuel flow is 0, so we turn on off this switch here to the run position. So you will see the fuel flowing boxed here with 0. We have the FADEC on for auto start, and we have the engine spinning again, the right wing engine, because we have a lot of fuel flow right now. So this is the right wing engine, the left wing engine. We can continue now with the rest of the items here. I will show you very quickly how to make the flight management computer setup. So initial reference, we have the 0 fuel weight, gross weight 189,600 kilograms plus the fuel for the 6,800, 236.4. I'm gonna use the reserves of 5% and cruising altitude 250. We're gonna have the temperature minus 37 degrees, cruising center of gravity, cost index 100. So we have less, maybe 36 minutes left for this flight. So we use the route departure and arrival from Lszh 8 back to Lszh 8. Departure and arrival airport, departure runway. This is the flight management computer part. So we're gonna have the flight plan and the takeoff speeds here. The departing runway, the departing fixes, and the arrival airport and runway, the arrival fixes. The legs, so we cancel the discontinuity for that and activate. So we have flaps 15, center of gravity 36% of the mean aerodynamic force. This is very important. This is what we need to do here. The CG, the center of gravity, the stabilizer trim the horizontal tail of the aircraft, which balances the center of gravity in flight. Aerodynamic forces. So we have V1 133, V0 141, V2 155. I'm gonna use this flap setting here. I'm gonna show you flaps here 15 degrees. You can see in 20 one more notch up, 15 degrees. So we have about a few more minutes to go. We have everything fixed for the takeoff. So disarm the parking brakes. You can see here the parking brakes. Disarm. Advance the thrust levers here. I will show you the flight plan maybe. So you can see the flight plan here, the horizontal flight plan. I'm gonna use you can see the map mode here. We have the runway and also the flight plan of the aircraft. This line. You can see even further. Port enough to come out. You'll see the terrain scan of the radar. So we're gonna use this range for this takeoff. So we disarm the parking brakes, advance the thrust levers, and use the tiller. We have no traffic now for this runway. So we are aligned here with the Ilsloc localizer on the runway. Parking brake again. So this is where we are positioned in this runway. We have about 33 minutes left for this flight. So I'm gonna come to initiate the takeoff now. You can see we have everything set up here in the primary flight display. In this radar display, we can even see the sea in front of us. We increase the range. So we use this range now. We have the autopilot set, the airspeed maybe is a little bit higher airspeed. On the LNAV path here, we have altitude hold, not vertical speed for this takeoff. So if we advance the thrust levers now, we can use also the takeoff go around switch that we use manual. So as you can see, the N1 increases. We can increase even further. To the takeoff go around position limit. So we disarm the brakes and go. Use the rudder pedals now to align. We have about 28 minutes left for this flight, so we have V1. We rotate, we pass the V-rotate. A small angle of attack to avoid a tail strike in the runway. So we keep gliding here. Maybe use a little bit less thrust. We have positive rate, retract the landing gear. We have like 28 minutes left for this flight. So we're gonna be flying manually. We have 36 minutes left for this flight. You can see the flight control sign put manually here. The yoke of the aircraft, the control column now pitching up, and the ailerons and the flaperons of the aircraft can make turns. So if I come here and show you the outside view of the aircraft while we fly. We're just 7,000 feet above the sea level. We have these beautiful views now. You can see the wings of the aircraft and its engine. Like its engines and wings, these are Boeing 777 has. You can see nice night skies here. View. So going back inside. We have the legs here. We're gonna use this the direct into the next waypoint. Execute. So we're flying into the next waypoint now. 15,000 feet. Keep flying manually. We have the nav on. Using the flight director so you can see inside. We have about 33 more minutes left for this flight. Keep climbing rapidly, as you can see. We're gonna be overflying the lake. So this is our spacecraft for tonight, the Boeing 777-300 ERX. So we have a beautiful night sky here with the galaxies, too many stars here, flying high, 19,000 feet. We're flying 20,000 feet above the sea level, about 18,000 feet above the ground level. Need to align with the flight plan here. Crossing 31,000 feet. In a while, 30,100. We need to retract some flaps here. You can see our airspeed is Mach 0.534, about 650 kilometers an hour or 244 knots. Now we climb a little bit faster, I believe. Across 31,000. Exhaust gas temperature, the N1 here. Have the N2 also. You can see the flight line here. We need to fly the next waypoint, the distance nautical miles to the next waypoint. Our rate of climb here 5,800 feet per minute. We need maybe to slow down a little bit the rate of climb. We retract some flaps. That is gonna slow down. You can see our tips up and tips down the stabilizer trim. 33,600 feet. So if I come outside, now we overflying the lake. The Switzerland here, the lake. Nice. And we also have the chemtrails now created from this from flying into the stratosphere right now, close to the stratosphere, above the troposphere of the Earth. So we are just a few more. Have to go inside again. Here we are in the flight level, leveling off. So maybe we have like 18 more minutes left for this flight. We're gonna be flying straight ahead. You can see here we have the German in front of us. We need to slow down the thrust now. That's why it's picking up. So these is this switch, I'm not sure. You can see the Mach 0.6 to 9 right now. I'm trying to balance this altitude. Maybe we track a few more flaps. We don't need so many. You can see the stall speed also marked in here with yellow. So flying manually right now, 35,000 feet. Holding level here. Trying to hold level. Maybe increase the airspeed a little bit. So we're gonna make a turn now. We're gonna be overflying the German in a while. Holding level here. You can see we're overflying Germany now. We have about 17 minutes. We flew past the lake now. And this is the Bavarian Alps region in Germany. With Munich in front of us. The Bayern Munich region in front of us. All this valley is Germany. So we're going back to Switzerland now to see we have this beautiful view here. This night sky. So we fly 35,800 feet right now above the sea level. We have to come back now. So making a turn now. Trying to pick down. Maybe use a higher altitude. We don't need. So we're going back into the airport. Maybe leveling off here to the 6,000 feet. The aerodynamic forces is pushing our speed. So we're gonna have the airport data back in front of us here. The next waypoint is 21 plus 40. Maybe we are 60 nautical miles away right now from the airport. So we bang roll here, overflying Switzerland and Germany borderline. Trying to pitch down. Hold this aircraft as much as I can level. 36,000 feet right now. So you can see we are 36,000. So this is our spacecraft for tonight, the Boeing 777-300 ERX, flying close to the stars and the galaxies, above, almost close to the stratosphere, in a high level of the troposphere of the Earth. You can see the engine here. So we go a level higher, 37,000 feet right now. We have about 15 minutes left for this flight. We flew past Germany, the Bavarian region, 38,600 feet right now. Maybe reach 39,000, I'm not sure. So we are closer now with this spacecraft. So 39,000. A little bit higher, 39,000 feet. It's more Mach speed right now. So we have 12 minutes left for this flight. Connect the autopilot and the flight level here, 39,000 feet. And here we're flying with a lot of Mach right now. So direct 2. We are 57 nautical miles away. So we need to descend actually now to this altitude, decrease airspeed. You can see the plan here, having back the map in the center. I need to set up one more thing for landing here. Landing 35 degrees and the airspeed for landing. So we'll go back into the lake. We're just 50 nautical miles away. Flying with the autopilot now. Have like 11 minutes left for this flight. It's making a very fast coming back into the airport. So overflying again Switzerland, overflying the lake. As you can see, this beautiful lake here. You can see how high we are right now because of our chemtrails. And this is the Boeing 777-300 our spacecraft for tonight. So we have 6 into 8, 10 minutes left. Maybe use a lower flight level now. Use this flight level change. .36 nautical miles away. Mach 0.67. We had Mach like 0.8, like 900 kilometers. Now we fly with 850 kilometers an hour. Quite fast. We have like 10 minutes to go for this flight. So we need to descend in 5 minutes and approach in another 5 minutes. So use the vertical speed. We can use the flight path angle. Yeah. Pretty much is the same. Use maybe some speed brakes to slow down as we descend. Mach 0.725. Keep flying with quite high Mach airspeed, so we have we have 18 minutes left for this flight. So we need to descend and approach very quickly in 8 minutes. It's quite unusual. So we need to make a very careful approach. 31,000 feet left, very high Mach speed, 35 nautical miles. Maybe we have 7 minutes left for this flight. $19,000 feet, 31 nautical miles away. We're gonna have the runway in front of us in a while. Still high. We're going with 750 kilometers an hour right now. Our airspeed. Have it cruising closer into the runway. Maybe 6 minutes left for this flight. So we need to make a huge shortcut for this runway as we descend. And fly faster. We're gonna be there in 2 minutes in this descent altitude. Very rapid descent. So we are closer now to Zurich and the airport. I'm gonna pass the river in a while. We have 5 minutes left. So 12 nautical miles away, we're very close into the river. We have the runway in sight, which is a good thing. We can fly manually now. Make a big shortcut, maybe disarm the autopilot. We have the warning here. We need also to slow down the airspeed now. So we have the river, we're gonna start turning now. We use also this mode here, slowing down the airspeed, coming closer to the runway, like 10 nautical miles away, 9,000 feet. Slow down the aircraft a little bit more. Use this 9,000 feet. There is the runway. We have like 4 minutes left for this flight, maybe. 8,000 feet. Need to slow down fast. So we have a lot of turbulence now, and use more flaps right now. Use maybe the landing airspeed for approach. Plus 5 knots. Have like 4 minutes left for this flight. 7,000 feet. So we have the river in front of us. Έλα. Περίμενε 2 λεπτά, έρχομαι, περίμενε. Περίμενε 5 λεπτά, θα έρθω εγώ. We're going with full flaps. 5,000 feet. Have like 3 minutes left for this flight. Keep pushing down the control column. $3,500 runway in front of us, but higher airspeed. So we make a visual VFR right now. So here we are. Keep trying to slow him down. $200 knots. Brakes and reverse thrust. We need to go around again. This is full takeoff, go around power. So here we go around again. We have 2 more minutes to go. Ready for this flight? I'm not sure. We're going around. Let's see, go around now. 2 more minutes left for this flight. 2 more minutes left for this video actually. Maybe if I'm lucky I need to regulate another one. So